Okay, so YouTube says we're live. Richard Wright from Software Bisque is with us tonight. Going to talk about all sorts of things related to Software Bisque. As you guys know, Project Terrell, we have one of the items in that observatory is a Paramount ME. And so we'll all get a chance to play with that, take a look at it, use it, things like that. Richard, go ahead and tell us a little bit about what you do, what you do with Software Bisque, and go ahead and do what you're going to do.
All right. Well, Software Bisque, just for the benefit of those who might not be very familiar with us or who watch the YouTube videos later, we've been in the astronomy software business for 30 years. Software Bisque is based in Golden, Colorado, and was formed by Steve Bisque and his three brothers and daughter work for them now. So it's a small family company. Flagship product is the Sky astronomy software, and of course the Paramount line of robotic telescope mounts. And I work remotely from Florida because well, up until this month, I also was teaching a class at a local university. And my main responsibility, I'm a software engineer, graphics and cross-platform technologies, and mobile stuff, and I'm also sort of the de facto imaging evangelist. So years ago, Tom Bisque used to go to star parties and show off the mounts and imaging stuff, and I'm sort of inherited that role. I really enjoyed imaging and talking to people, and so it was just kind of it was a good fit. So tonight's topic is, of course, the Paramount imaging workflow. So it's about the Paramounts and how to use them and how to image with them. I'm going to switch over to screen share and go to my desktop, and there, start screen sharing. Here we go. Now I'm screen sharing, and you can see yourself probably. So where's the button I'm looking for? I did rehearse this. Here we go. So first, okay, so here's my little photo album. First thing, of course, Paramount workflow starts with picking a Paramount, and this is a picture of the Paramount ME being used by NASA. And if you have the funds, the Paramount is, or the resources, of course, it could be considered a portable mount. The ME's been replaced by the ME2 now. And that is also a very beefy mount. The currently payload capacity on the ME2 is 240 pounds. This is at the Winter Star Party last year. We had a 20-inch corrected RC from Officina Stellare on there, and that's 8 30-pound counterweights on that tripod, and we successfully imaged. This is a package we make for the Air Force for a contract for them, but it's also available, of course, to amateurs. And if you have a large observatory, the Paramount ME2 is a good choice. A few years ago, we introduced the Paramount MX, which at the time was our, we built that as our portable mount. Imaging on the go, take it different places. Here it is. I took it to GMARS and was imaging there, which is a great dark sky site in California. Well, you guys in San Diego, some of you have probably been to GMARS. And then just yesterday, we announced the Paramount Mighty, which, let me show you the whole lineup here. This is the Paramount Mighty. If you can see, can you guys see my cursor if I move it around like this?
Yeah.
Can you see what I'm pointing at? All right. So this is the ME2, 30-pound counterweights, and this is the MX Plus. This has a payload capacity of 240 pounds and weighs 84 pounds. It's quite heavy to move around by hand. The MX Plus weighs 50 pounds and has a payload capacity of 100 pounds. And this is a great mount for backyard observatories or small observatories with a moderate payload. This is the new Mighty, which weighs 34 pounds and has a payload capacity of 50 pounds. And these, we actually, for the first time ever, we managed to keep this a secret almost all the way up until we released it. We announced the MX when we first said, hey, let's build an MX, and people quit buying mounts, and so we kind of learned our lesson from that. But we actually finished our first production run of this. We built prototypes early in the summer, and Tom Bisk and I have been using the prototype for imaging on the road and there in Golden. And the first production mount, actually, I have the first production mount, so I had that this weekend doing field trials, and it's a great little Paramount. It's ideal for small payloads. If you have a small scope and you want to use the Paramount workflow, which we're going to talk about, this is more ideal. This is a 10-pound counterweight here on the bottom. And when I used to put this or my Takahashi, I've got a small Takahashi FC76, not even a baby Q. But when I put it on the MX, the 20-pound counterweight was too much for it. So no counterweight, it was too out of balance. One counterweight, it was too out of balance the other way. And so I've been begging for a small Paramount for a long time. Of course, it has a 50-pound payload capacity. So this is my 8-inch Veloce. This is a Riccardi Honders from Officina Stellari. It's actually a pretty heavy scope. It's only 8-inch scope, but it weighs about 35 pounds with the rings and everything. And the Mighty mount handles this just perfectly. I took it up to a place in North Carolina where I like to go image and set it up there, and it runs very well there. Now, Paramount. I'm going to show you the back. The Mighty. This is actually the back of the Mighty, but all the Paramounts look like this on the back. There's a number of nice things that we have going on here. One, there's just one USB going into the mount, and you can see here cables running up to the VersaPlate. Up on the VersaPlate, we have 2 USB ports. We also have 2 power connectors, a 5-volt and 12-volt for low voltage things like focusers or filter wheels, something that needs just a little bit of current. You can also run your own cables through the mount. This little opening here with a little thing keeps rodents, and for here in Florida it's mostly lizards from getting inside there, and you can run that very easily up through to the top of it. And then these are what are these called? Oh yeah, the Keystone modules. So you could run coax or Ethernet through, and they make these little Keystone. I went and Googled to get a picture of some of them. You get these things, and they're just kind of a commodity adapter. So you put your wire on it, crimp it, and then you can plug it in very easily to the mount. Down here at the bottom we have. I'm sorry, go ahead.
USB port powered? The little hub, there you go.
The hub is powered, yes.
Okay.
Yes, the USB hub is powered. I run cameras off of it. I do have, first and second tier cameras. I really don't have any trouble running them off of that hub. USB is it was never really meant, I don't think it was intended to have a lot of high-speed devices. It was invented for, hard drives and mice and keyboards and printers and things. And the specs can be very difficult to adhere to, and a lot of people cut corners, and they work, but you start piling them together, and you can run into some problems. Some of the the budget devices and cameras sometimes won't work through the hub, and you'll have to run them through the mount and plug them directly into your laptop. And even some laptops don't handle multiple USB devices very well. Sometimes they'll have one USB controller, and even though you've got 3 or 4 USB ports on your laptop, it's actually doing like a time slice, and it's sharing all of those USB ports on really what's one USB port. The more expensive laptops will have a dedicated controller for each USB port, and those are a lot more reliable, certainly for like remote applications. But even if you're not remote and you're setting up, you really don't want the hassle of USB things crashing on you on a regular basis. But our hub is industrial grade, and it meets the USB specs. And when it gets cold, it doesn't quit working, or when it gets a lot of dew, it doesn't quit. We also have additional auxiliary power that you can run through the mount. This has 2 conduits, and we make adapters. You could make your own adapters to run them through. I run my dew heater through here and my camera, cooled CCD camera through here. One of them is rated at 3 amps, the other is rated at 5 amps. So I use 5 amps for the dew heater, and I use the 3 amps for the cooled CCD camera. Oh, and I mentioned at the top they have the 12-volt power supply. I actually run DSLRs off of that. I made my own adapter that converts 12 volts into what my Canon DSLR wants, and I can run the Canon DSLR right off the VersaPlate and then run the mount off of battery, and I can do the whole imaging run, with just one battery. The Paramounts are 48 volts. I know a lot of mounts are 12 volts, and for some people this is a sticking point. They want to know why we can't just make our mount run off of 12 volts like everybody else. And it's kind of like the difference between unleaded fuel and diesel fuel. If you're going to build a big truck, you don't want to build it to run off of unleaded fuel. Running off diesel has its challenges, but it solves an awful lot of problems. And the same thing with the 48 volts solves a lot of problems. We do provide an AC adapter that goes to 48 volts. We also have a battery that is it's quite expensive. I'm not going to lie, but it's a lithium iron phosphate battery. They have about 5 times the energy density of a lead acid battery, so it's extremely light, and they're impervious to cold, and you can drill a hole in them and they won't catch on fire like a lithium ion battery will, and of course they don't have acid in them like a lead acid battery. You could make your own 48 volt power supply with 12 volt batteries, of course, wired in series. The lithium iron, the lithium iron phosphate batteries, the reason they're so, we're not gouging people, they're actually quite expensive. I found my own supplier for a 12 volt version to run my CCD camera, and by the time I got one that would run my CCD for 2 days, it was close to $500 for it. Now, brand new, you guys are the first ones that were telling about this, is we've been doing some R&D ourselves, and we found, we require 48 volts, but actually the control system can handle up to 60 volts. You definitely don't want to go over 60 volts, but you could go to Home Depot and you can get these 56 volt batteries that are designed for lawn equipment. So these things run your electric lawnmower or your electric weed eater and things like that. So this is a much more economical. They don't last as long as the high-end batteries that we sell, but we're going to make an adapter for these. This is, of course, isn't endorsed by Home Depot or by these ego people, but these are quite nice batteries, and they'll run them out for a couple of days on a full charge. At least the 4 amp hour version will. And so we think that's going to address a lot of people's concern about wanting to get a low-cost battery that's going to run their mount, their portable mount, especially now that we're shipping the Mighty or the Mighty mount, because it's really going to be geared more towards the portable market. And there's an antenna on the back here. I should mention that as well. We do have an optional Wi-Fi daughter board that you can put on there, and you can control the mount via Wi-Fi. And that's via either a laptop with Wi-Fi or an iPhone or an iPad. We have the Sky on iOS now, and you can actually run the mount without a computer if you're interested in imaging. And I take a picture showing. I don't have a picture showing my Takahashi, but you can connect to this with the iPad, slew around, find objects. And switch them. So it's nice, that, especially for the Mighty mount, because a lot of people doing outreach. We've got a couple of outreach organizations that have MXs and they use them portably, and they do that. They'll use an iPad to control the mount. But on weekends or when they have their own time, they'll do imaging with the mount as well. And so, okay. And the mounts come with, of course, with our full software suite. So you get the SkyX Pro, which is our flagship. Hang on, I want to switch back to you guys. It's going to take me a while to figure out Google Hangouts. Hey, look at that. Can you guys see me? No.
No, see us.
You are screen sharing. Okay, no, this is all me. I stopped screen sharing, so now, yeah, there we go. No, wait a minute.
There you go.
All right, hello. Yeah, so just now the talking part. The mounts come with over $1,000 worth of software. The SkyX Pro, which has, including the camera add-on, you get our plate solving technology, camera control, guiding with dithering, the T-Point advanced mount modeling software, the full suite for both Windows and Macintosh, whichever you want, or actually both, for that matter. And I'm going to go over basically how to use all of that in the rest of the talk. So before I start a video or do anything like that, this is kind of like a good spot to go. Any questions about what I've talked about so far, about the mounts themselves, about the hardware or the Mighty Mount, or anything along those lines?
Well, I didn't see a place for a polar scope to do any kind of polar alignment, and if you're marketing a portable mount, I'm curious as to how that works with a Paramount.
That is coming up next. Coming up next. You do not need a polar scope. So I'm going to show you the video. I made a video down at the observatory on how to polar align a Paramount. The key is, the reason I'll tell you in advance, that the reason you polar align first with a polar scope is most mounts don't know where they are, even relative to themselves. So the idea is you line up the right ascension axis with the pole, and then you know where you are and what time it is. So you can slew to a star, and you synchronize on that star. And what that does is it tells the mount where it is, as much as anything else. Well, the Paramounts have a homing sensor in them, so they know where they are. You can actually polar align a Paramount during the day because the right ascension axis and the declination axis are orthogonal to one another. So you can actually point at any object in the sky, and if you move the mount to where it's pointing at the object and the mount is level, then you've actually lined up the polar axis as well. I think I'm going to get some Tinker Toys and try to use that as a demonstration and say, let's see how this axis moves as you move that, and it actually aligns the polar axis for you all in one goal. And then of course we have T-point assisted polar alignment, which is sort of a 21st century version of the drift alignment. Only a lot faster than drift alignment and a lot more accurate because it takes into account all the different things about your optical system that may not be really square with your mount's equipment.
Richard, is there GPS built into the Mighty Mount?
No, we don't have a GPS built into the mount. If you're using yeah, no, we don't have one. We've been talking for years about adding a GPS to the mount. They do have a temperature probe in them, and we now have temperature compensated focusing, and it can feed off of the mount's temperature probe. So if you have a focuser that doesn't come with its own temperature probe, the mount knows what temperature it is. In fact, that's a good hardware question. You can actually set the mount to slow the slew rate down. Not the tracking rate, but the slew rate when it gets cold, so that you're not over torquing it in cold weather when the grease is getting stiff and whatnot. And, you do a sudden slew across the sky. Yeah. Okay. Was that? I didn't catch that.
GPS. Why don't you have it available?
Why don't we? It's expensive and takes a lot of development time, and everybody on the planet has a phone with a GPS in it.
Nowadays, you kind of got one of these.
What's that?
Oh, yeah, that's right.
I used to joke when many years ago I had an LX200 that had a GPS, and the GPS board went out on it, and I always told people it worked better broke, because I could do the alignment faster than waiting on the hand controller to find itself and slew around it. But anyway, that I'm not speaking for software BIS there, but GPS, it's on the wish list to put it in the mount. We're actually working on, we have the iOS and the Android, and those devices also have GPSs in them as well. And we're working on a little Linux box that's going to go in the mount, and we may add the GPS to that. That may be the way we go with that. But yeah. All right. Any other questions about the mount itself or the hardware? Okay, then, David, it's movie time. We're going to play the MX
Rick,
setup video.
You didn't mention one other question. You didn't mention the pricing on the Mighty mount.
The pricing on the Mighty, it's $6,000. So the Mighty is $6,000, the MX Plus is $9,000, and the ME2 is $13,000.
And that's with all the software?
That's with all the software, yes. So it's easily it's more than $1,000 worth of software. Yeah. Okay, so David, are you ready to do the screen share?
Yep.
All right. I'm assuming something pops up and says "Help David" like it did the last time.
I assume it would.
All right. Standing by.
Are you trying to help me now? Does it say
No, nothing is showing up saying "Help David."
I wonder if this is kind of one of these experiments. I don't know if we can do this when we're actually live broadcasting. So why don't I do this? I'm going to go ahead and switch my desktop over real quick. Which video would you like to play?
The MX setup, and the reason is the first thing you need to do is polar align your scope, right? So the MX setup is basically intended to show you how to set up and polar align your scope. So let's MX setup.
All right.
MX setup. Play it. This. Today I'm going to show you how to quickly set up and polar align your camera when you're on the road. This is my dark sky site in South Florida. But we could just as easily be at a state park or start party or your own backyard. This technique works wherever you are. And you don't need one of these things, so you can set up and go any time you have. We picked around 2 hours or all day in the dark sky site. Time is of the essence. And you don't want to be wasting starlight tweaking your alignment trying to get your track going. So, there was a lot of wind that day. Right now, always show up your dark sky site plenty early so that you have plenty of daylight. You can set up, be organized, find that missing piece of little black wire at the bottom of the dark container somewhere. Don't wait until you're racing the setting sun or trying to set up in the dark during the twilight. And if it's a star party, doubly so, because there's lots of chit chat. People want to come and see what you're doing. Nothing wrong with that, so we go to star parties, but it does take a little extra time to get set up, and you should factor that in. The foundation of your mount is your portable gear or tripod. Here I have a software BIS pyramid portable gear, and I have it set on 3 fingers that are set down into the grass so it can be stable during the night. Now, the software BIS portable gear has 3 important features for the portable imager. Number 1, it's light, only 20 pounds. It's very easy to transport. Second, the head loosens very easily with very easy as-is adjustments of your mount. And you tighten it back down with your hand only, and it's stable for the rest of the night. Third are these micro levelers, making it very easy to make small, tiny adjustments to get your mount as level as possible. There's even a bubble level on the top to help you get it right.
having a good level mount is key to one-star polar alignment trick I'm going to show you in a few minutes. Yeah, I'm pretty happy with that. Now, if you can't find a good hard surface to set up on, or on grass, if it's allowed where you are, you might need to dig up a little bit of grass so that you get the feet down to the solid ground underneath the grass. What happens during the night is there'll be some settling. Of course, that's going to throw off your hard-on polar alignment. You don't want that to happen. Also, when you're trying to get level, you can, with an Allen wrench, adjust these bottom feet. Give or take a few more inches, and it gives you quite a bit more room for. It's very hard to find level ground sometimes, yes. Now that I have a level tripod here, I put the paramount on and counterweight tension shaft. I'm not going to load the paramount down with the scope or counterweights just yet. And I'm also not going to tighten the azimuth adjustment. That's going to be one of the last adjustments and tweaks that we make. The next thing I'm going to do is set the altitude. Now, all paramounts have these tick marks to show the elevation. You're going to set this to your current latitude, which for me is about 27 degrees. You can go down just a little bit, and so it's not good. I'm also not going to tighten my altitude retaining object because I'm going to do some fine tuning to this in a minute. Now I'm just about ready to go mechanically. The mount's on, the altitude set, I'm more or less pointed north. Next thing I'm going to do is my one-star alignment. But I'm not going to wait till it's dark to do that, and then your computer plug into the mount next. Paramount User's Guide outlines a procedure called the Quick Polar Alignment Method. And it has you do pretty much what we just did. It then tells you to salute to a bright star and center it in the telescope using only mechanical adjustments to the mount. Don't use the handheld or the computer at all. I'm going to do the same thing, except I'm not going to wait till it's dark. I'm going to use the brightest star in our sky, the sun, and I can do this during the daytime. I've just built a mount to salute to the sun. And of course, you can do this with a telescope on it, but I don't recommend it unless your scope is really well covered. If you have one of those open trust scopes, I really wouldn't trust that at all. Since I haven't tightened down the head, I can very easily turn my mount and slant down the dorsal plate to where the sun lines up. Now, I'm not going to recommend that you stare at the sun. There are a number of products on the market that help you point at the sun for solar observers and imagers, and you can pull in one of those. Oh, too, a friend made for me. It's got a pinhole on one end and a projector screen on the other. And I can lie that right inside the first plate. And I can adjust this until the sun's disk makes a little image on that. And then I know I'm pointing straight at the sun. Any adjustments in altitude should be very, very small. You set it to our latitude earlier. So you should be just about there. And then you want to do little fine tunings if your mount, of course, is level. We only want to do very fine tuned tweaks to get it good. I've just completed my one-star alignment during the daytime. I can disengage the worms, lock it down, load my equipment, balance it, get everything ready to go before twilight gets here. Once twilight comes, all I have to do is rehome the mount, and I'm good to go. With practice, I'm consistently 5 to 10 arc minutes off the pole now with this technique whenever I'm doing portable imaging, which is good enough for a lot of focal lengths to avoid field rotation in a single sub. Now, if you're shooting at a longer focal length, or you want to shoot for a really long time, perhaps with narrowband, then you might want to tweak your polar alignment just a little bit more. And in the next video, I'm going to show you how to do that with T-point. You can do it all during twilight without wasting any valuable imaging time.
Thanks, David.
All right, back at you.
All right. So there is no next video. I'm actually just going to show you that live using the camera simulator and the DSS database to pretend like I'm taking pictures. But first, I want to just kind of review what I talked about in the video, and then see if there's any questions about it. Homing the mount. What that is the mount initializes itself to be. It's about hour angle 2 at declination 0, and the mount slews to that position. And we have encoders on the motors, and there's a homing sensor that can tell when when both axes are at that location. So the mount it zeroes out the mount axis, so it knows where it is. And the Paramount is actually the only mount on the market, other than the ones with absolute encoders, that can do that. Otherwise, you can't do a daytime polar alignment, by slowing to another object, because the mount doesn't actually physically know where it is. But because all these axes are at a fixed angle to one another, this works really well. It works especially well when the sun is setting. You really don't want to do it on a star that's real high in the sky. But as the sun is going down, you get very good azimuth and very good altitude adjustments. Like I said, most of the time I'm about 5 minutes off the pole. I determine that by doing a lengthy T-point analysis afterwards. And 5 minutes is if you're guiding, 5 minutes is plenty close to the pole for most purposes. And I'm going to show you how to do the sync using a camera and so forth in a minute using the software. But first, are we good? Questions? Anybody want any clarification about anything I said in the video? No? Okay, I see nobody's shaking their head. All right. So let's try and press this button again. And I'm going to select my desktop. And I think we're good to go. My email. You guys see the sky on my desktop?
No, we see your email.
No, my email is closed.
There you go.
Okay.
That
There's
was-
a bit of a delay. I should probably close that email. There might be some messages there. All right. Well, I've connected to. We have a mount simulator in the sky, so it thinks it's connected to a mount, and I'm connected to a camera simulator. It thinks it's a pretend camera, and I'm using the DSS database, so I can actually take a photograph or pretend to take a photograph anywhere in the sky. And right now I'm pointing somewhere north. So as I said in the video, I'm pretty close to the pole, but I may not be as close as I'd like to be. So now that it's getting dark and I can get stars on a camera sensor, I can slew pretty much anywhere and take a picture. I'm going to take a very short it's not really a 1 second exposure, but since it's simulated, I can get away with it, and we don't have to wait. So there's a bit of lag, I know, on the screen. So do you guys see an image with a star in it?
Oh,
see
yeah.
the screen? Okay. So we have a feature in the sky called ImageLink, which is our plate solving solution, and we've been doing this for well over 15 years, and our competitors do the same thing because it's an extraordinarily useful thing to be able to do. You want to look at all these stars in the image and do pattern matching and figure out where you're actually pointing. The scope thinks it's pointing at a certain right ascension and declination, but you can take an image and do the pattern match, and you can tell where it actually is pointing in right ascension and declination. And the difference between those two tells you how far off you are on your initial pointing model. To do the image link, you just select image link from the FITS viewer menu, and it'll bring up a dialog. And if you know the image scale, you can put that in. It usually works a little faster if you know the image scale. If you don't know the image scale, there's a radio button for that. And then when you run it, it finds all the stars. Now the purple lines, if you see those are for developers only. We don't. You don't see those purple lines. We're actually matching triangles from the stars, and we've got a little bit of debug code in the developer version so that we can kind of keep an eye on things, and if something goes wrong, we have some idea what went wrong. Over here, I've got a report, and it's showing me the exact center, right ascension, and declination. It tells me the scale. The pixel scale is 1.7 arc seconds per pixel. Gives me the position angle, number of stars that it used in the solution. It even gives me an average full width half maximum on the image. Now, of course, this is DSS data, so it's not a real image. When you image link a photo, you have the option of displaying it right on the sky chart. And so here it is overlaid over top of my sky chart, and I can select the image linked photo. There we go. It says linked photo. And when I'm initializing my mount at the beginning of the night, I go over and I can synchronize on that particular image linked photo. I have friends that I see them even with Paramounts. They don't know that you can do this, synchronize on an image-linked photo, and they'll spend a lot of time at the beginning of the night centering a star. They'll bring up the little reticle and they'll scooch the mount a little to the left and a little up, and when the star's in the middle, then they'll sync on it. And I'm like, take a picture, select sync. It takes 20 seconds instead of 5 minutes. And everything that you can do like that is going to speed up getting ready to go. Now I've created, I've done my initial sync, and that kind of gets the mount ready to go. I can start slewing around. If my alignment is exceptionally good and my focal length isn't too horrible and everything is all lined up, I'll probably get reasonable pointing. If I was doing visual with an eyepiece, I might get the object I'm looking for in my field of view. If I want to slew to a particular object, I can actually use this image link feature to get right to the object. We have a feature called closed loop slew. So, say I want to let's look up and see what's up there. Let's say I want to slew to M33. So I'll search for M33, and instead of slew, I'll do closed loop slew. And what it does is it slews to the object, and this is without even doing a T-point model or having to do anything else. This is ready to go right now. It takes a picture. It does a plate solve on this. My alignment is pretty good in my simulator, you can see. But it'll do a plate solve and see how far off it is, and then it'll move the mount and take another picture and do another plate solve, and it'll iterate that until the object that you've selected is completely centered on the screen. So without even having to do any model, if I was in a very big hurry, I literally could be ready to image right now as long as my guider was calibrated. Now, if you want to take your pointing up the next step. Let me get rid of that linked photo there. Then you want to build a T-point model, a model of your mount. And the way you do that is let me take a picture. I'll show you how to do it manually first. And I'll take an image. I clicked connect, not take photo. I'll take an image. I'll plate solve it. Go to image link. Say find my solution. Okay, image link succeeded. Select the image. And sometimes it's hard to find the exact image, so I'm going to select it this way. And then I'm going to add this as a pointing sample. And T-Point is our mount modeling software. We actually licensed this from Patrick Wallace. This is used in every major observatory in the world, up to the largest ones, up to the largest telescopes in the world. And it models flexures in your system, how much the telescope bends, how much it twists at certain angles. And you can build one of these models for your system. So I just added my first point to the model. Now you could slew all over the sky. When I first started imaging, this was fun. It was like playing video games. I could go, okay, slew to this object, take a picture, add the model, and yeah, okay, that just takes way too much time. So we have an automated calibration routine. You can bring up bring up the T-point dialog, and the automated calibration. You can set up the exposure time, your scale, your binning, and then you can tell it where in the sky to collect data. So you can adjust, say, from 35 degrees up. You can change, say, part of the sky is not visible from your house, so I can select, only model that much of the sky. And once, then I just say go. And I'm going to show pointing targets on the sky, and hopefully you can see this animation. So there is a series of yellow circles with a yellow line between them, and this is tracing out the path. And the mount takes a picture, plate solves it, adds it to the model, and then slews to the next point, takes a picture, plate solves it, adds it to the model, and it'll do this in an automated fashion. And I can get some fairly good models built before twilight comes. You know, when you're setting up at dusk, you can get stars on your sensor not very long after sunset. It's not time to image yet. You need to wait till the sky is good and dark, possibly even longer if your scope needs to cool off or the atmosphere needs to stabilize. This pointing run, you can do about 12 points and get very good guiding at moderate focal lengths in about 10 minutes. And you can get better, well, you get very good pointing. I'm going to let this run a little bit. Well, no, I'm going to stop it because it's real boring to watch it at a certain point. Once you've built your model and you have, let's say we have a lot of points here, which I don't, you can click on the polar alignment tab. Now right here, of course, it says no, I don't have enough samples, but with about a dozen samples, it'll actually tell you how far off your best how far off your polar alignment is, how many arc seconds or arc minutes you need to lower or raise the mount, and how many arc seconds or arc minutes you need to adjust the mount in azimuth. The paramounts have calibrated adjustment knobs on them, so it'll actually tell you, loosen the left knob, tighten the right knob, 18.2 ticks. Raise the mount, 3.7 ticks. You make those adjustments, and that gets you, that's all you need to do. You're now really very close to the pole. We have a new feature coming out this fall where when you make those adjustments, you can actually do it with a live camera. So it'll slew to a star and put a reticle up, and then it tells you how to, it slews off, and then you recenter the mount using the mount physical control so that the star is back in the middle of the reticle. And I tried that for the first time this weekend. It only took one adjustment, and I was right on the pole, just about 2 arc minutes off the pole in one shot. And it takes a lot less time than doing a drift alignment, and I didn't need Polaris to be visible, and I got started before it was even dark. And come astronomical twilight, I was ready to image, and I couldn't because the sky was still wiggling around too much. But I image portably all the time, and I'm always ready to go by the time astronomical twilight arrives, and I have very good polar alignment. If a better option than guiding actually is if you build a very dense model. We have a feature called ProTrack, where we use all that information, all those pointing samples, and it models the flexures in your system. Sometimes things change because of refraction in the atmosphere, or as you slew from the horizon to higher in the sky, things in your mount flex slightly. So it's not always necessarily about the mount. It's about the entire optical train. The telescope flexes, your focuser flexes, and if it flexes repeatably, then T-Point can model that out. And we have customers who are getting 20-minute or more unguided exposures, at 2 and 3 meter focal lengths. I shoot pretty short. I shoot about 2,000 millimeters or under, and I can do 10, 15, 20-minute exposures on a regular basis. Now, this, of course, makes everything has to be really top-notch. Your scope has to be on rings and not mounted willy-nilly, and you can't have a $300 focuser well, $300 actually isn't bad. You can't have a plastic focuser that's wobbling back and forth as you slew around in the sky. But T-Point and ProTrack are kind of the hallmarks of the Paramount system. The ability to go long periods without having to guide is really a very nice thing. Our competitors usually have to resort to absolute encoders and some kind of pointing or mount analysis software. T-Point is really it's the best and most advanced pointing analysis software on the market, and it's available for the high-end professionals, and it's available in the amateur market. We have an exclusive on that. So,
question,
yeah,
Richard?
Sure.
Operation routine, you showed it picking a whole family of target points. Can you select the target points yourself, or can you delete individual target points that are not? I mean, you showed it deleting a whole quadrant where maybe you couldn't see in the sky, but can you individually delete target points?
I'm not sure. I've never tried that. You can add points. You can just click in here and add some user selected points.
Ah, okay.
So you can add them, and let's see if over here there's not a way to delete points.
But can you add them in that quadrant that you just deleted?
Yeah, I could go over here and say, yeah, even though I don't want you to go over here, I want you to add a few. You see where I'm doing that? I don't know if it's coming through.
Yeah.
Okay, yes, you can add them wherever you want. There's a little spot up here, I forget what NCP stands for, but there's a magic spot around the Polaris, and you're supposed to have at least a couple of points in that region. So that's always highlighted. Also, when you're connected to a Paramount, it doesn't work with the simulator, but it actually puts a little mark on here, shows you where the mount currently is. So you could, you could pick some points around where you flew to a clear part of the sky. I've done this before with remote. I go out and there's clouds, and it's supposed to clear later, but right now half the sky is clear or a quarter of the sky is clear, and I'll grab some points in that part of the sky. And then the clouds move, and I'll grab some points in the next part of the sky. And when it does finally clear out at midnight, boom, I'm ready to go immediately. I don't have to start. I don't want to get started then. I was going to ask for a show of hands, how many of you are portable imagers, but that won't work because I can't see you. Another nice feature of ImageLink is kind of with the closed-loop slew, multi-night imaging runs. Of course, here's my I screwed up all these. I added all those points by hand. You can see it's added them to my chart. For multiple night runs, I'm going to open up.
So is that, Richard, is that showing the path that it'll take?
Yeah, that's showing the path. And yeah, that's showing the path. And I clicked all kinds of crazy things, so that's why it looks weird.
Oh.
So for multi-night imaging, or even multi-year imaging, so I'm going to pull up an image. Here's a HA image of the IC 1396. There's the elephant trunk right there, and I took this last year, and I kind of want to finish this year and get some more data on it. So I can pull up this old image, and I can image link that. Say that is not at 1.7 pixels. So I'm gonna tell it that it's unknown. I'll let it solve it, and it'll solve that image. And so here's my image from last year, overlaid on the chart, and I can select that image. Select the image. There we go. And I can do a closed-loop slew on the image. The telescope will slew exactly to where this image is, and take a picture and plate solve it and adjust it. So I can go back with a new mount, a new camera, a year later, and I can match up this spot exactly on the sky. Just that easy. Also, our image link, we have a blind image link. We've had that for years. Let me pull that up. I'll open the same FITS file.
Richard,
If you're just setting up somewhere and you don't know where you're pointing, and this happened to me when I was just starting, trying to find a star. you can see the Big Dipper from your house, and then you go out to a dark sky site and you can't find the Big Dipper because there's so many daggone stars everywhere. And you can go to ImageLink. ImageLink works really fast if it knows approximately where you're pointing. But if you don't know where you're pointing at all, you can use All Sky ImageLink. We've had this feature for a long time, but it was very difficult to use, and you had to build your own database and all kinds of crazy things. It was like a rocket science sort of science fair thing. Now, we have a button, blind, find image, and it does everything. It goes, okay, I'm going to guess at the scale, and if I'm wrong, I'm going to change the scale and guess again, and your image is just too big with too many stars, so I'm going to crop it out and look at just the center. It does a lot of it's a built-in expert system, so if you have no idea where you're pointing, it'll still find that image and tell you where it is. Or you just found an image, there's nothing in the FITS header, you don't know where it was you took, but it looks interesting, and you want to know where it is, you can use All Sky and it'll find it for you automatically. So I'm looking at my notes for things to talk about.
Richard, none of the stuff that the software and the T-point and all that, none of that requires the Paramount mounts, right? I mean, it'll work on any mount.
Oh, actually, the only thing I've shown you so far that requires a Paramount is ProTrack, which is the long unguided exposures. The T-point pointing model works with any German equatorial mount. The T-point polar alignment advice works with any German equatorial mount. ProTrack makes real-time adjustments on the order of 4,000 times per second right to the control system of the mount, and so that does require a Paramount. The ASCOM guys have come up with something that's similar called.
ProTrack is the guiding function.
Oh yes, I'm going to show you guiding next.
No, he asked what ProTrack does. It's your not guiding.
No, ProTrack is not guiding at all. ProTrack figures out how much mount flexes and how much refraction there is, and it modifies the tracking rate. It modifies the tracking rate of the mount on the fly to account for flexures and other.
The T-point mount model to correct the pointing.
Yes, but not just to correct the pointing. It actually corrects the tracking too. That's what ProTrack does. Does that make sense?
But what's the point? Why wouldn't I just buy a $300 guider? Why would I want to bother with ProTrack? There must be some very specific reason why you went to all that trouble.
You get better contrast. If you think about what a guider does, the star smears, and you've detected that the star is smearing, and so now you correct it on the spot. So you will get a little better contrast and sharpness to your images with ProTrack than you will with guiding. There's no denying though that guiding is definitely if I need to get it set up real quick, just guide, and it works fine. So it's one of those, one-shot color or monochrome with filters. At a certain point, you want to take it to the next level, and ProTrack is one of those things that you can do to take it to the next level without having to guide.
How long if I'm a portable imager, how long does it take to set up ProTrack each night?
About an hour and a half. I would say maximum an hour to an hour and a half. Okay. And I can do it during twilight. It's surprising, only 10 or 15 minutes after sunset you can find stars with the CCD, and ImageLink will start kicking in. So the sky is still fairly bright, but you can get stars and do pattern matching and start slewing around. So I'm always ready to go, by the time the atmosphere and the temperature is ready for me. I don't waste any. I don't want to waste any dark sky time.
And if I have a permanent installation, if I have an ME mounted permanently, can I build one ProTrack model and then use it night after night after night? Or is it
Yes, yes, absolutely, absolutely. That's really the ideal thing. If you're portable, you know, you know how if you're going out by yourself, it's one thing. But when I go down even to my dark sky site, I got Admiral Jones on one side, and I got another guy on the other side, and they always want to talk to me, and they, you know, imaging. It's a social thing, and a lot of times I want to say, leave me the heck alone. I'm trying to get set up here. I'm glad you're set up, but I'm not. Please go away until I am. That just doesn't go over very well, right? Some of you may do that, but I don't do that. So you know, frequently I will guide from down there, and I have a dome, a small dome, and I'll set up a ProTrack. I'll set up a model there, and I'll leave that going. But if I set up on a tripod, a lot of times I'll just go ahead and guide. It also depends on the focal length that I'm shooting at and what optic I'm using as to whether I'll try to use ProTrack. You know, I write a lot of device drivers, and so sometimes I use stuff that's not that great, and I know that it's not going to stand. I know it's not going to flex repeatably, and so it's going to be hard to model. You can't model random stuff, so you really have to have a tight ship if you're going to do ProTrack. So, all right. Any other questions? I'm going to look at my notes. Yeah.
Can't you sync into an existing model?
Yes. Oh, and that reminds me about this. Setting up a model once. If you're portable and you do a ProTrack and you do a dense T-point model to do ProTrack, and this happened to me at a star party. During the night, the mount settled because you know you're setting up on grass or you try to dig it out as best you can, but your mount settles a little bit, or somebody bumps the mount, or you change cameras, and so that disrupts the model. There's a recalibration function that only takes about 12 points, and it recalibrates the existing one. So if the mount settles, it really doesn't change things like the flexure or any of the other computed, you know, I keep wanting to say non-orthogonalities, but that's a geek word. Most people don't know what that means. But the things in your system that aren't really straight, like they need to be, T-Point actually figures that out. There are terms in there that can actually tell you how high the front of your scope is relative to the back of your scope. It can untangle that from the model. So if it settles a little bit, or you know, here in Florida, even a permanent installation. We get a lot of rain. The ground swells, and it moves your mount, and so now you're a couple of seconds or arc minutes off from where you were. You can run a very quick recalibration on your model and get your ProTrack tracking back and get your T-point pointing model back online pretty quick. Okay. Any other questions about T-point and ProTrack? Kind of a very quick overview of it. So we do have focuser support. I'm going to switch back to my screen share real quick. We're going to do our videos. We're going to do the next video soon. The calibration video, David, will be coming up soon. And see, we're about an hour in here. Okay, so I'm screen sharing now. So the camera add-on, which comes with the Paramount, it controls the camera, which you've seen me kind of use that. You can set exposure time and delays and binning, and if you have a filter, you can set your filter up as well. But we also have focuser support, and you can manually adjust the focuser or do automated focusing runs. On the camera tab, we have a focus tab, and we can pop up a little graph. We've got a little 3D star profile that you can move around to see how it's going. And when you run at focus 2, it'll actually create what everybody likes to call the V curve. I'll tell you a secret. It's not really linear. It's actually a parabola. Is the curve that we're fitting to that, and it'll back the focuser out and check the star radius, and it goes through there and it calculates the optimal focus position at that particular time. You actually don't have to be very close to focus for ImageLink to work. You can do a rough focus at the beginning of the night. As long as you've got stars instead of donuts, ImageLink will work just fine. There's not really a lot of point in obsessing over focus at the beginning of the night because the atmosphere usually isn't that stable, and the thermal characteristics of your optics probably haven't settled down very much either. Once you're ready to image, focus then. And of course we have auto guiding, and it's really kind of hard to simulate auto guiding. So I made a video, and I'm going to go back and turn off screen sharing and ask David to play the video. There's two of them. There's one called Calibrate, and I made this because a lot of people used other guiding packages and they couldn't figure out how to use our guiding package. So I made this video, and a lot of people said it helped them figure out how to do the calibration and how to guide. So whenever you're ready to play.
This is calibration, correct?
Yes.
Taking a 4-second image with no subframe just to evaluate the field and look and see if I have enough stars.
Are there 2 instances going?
There must be 2 instances. Hang on, we got to. See, you're laughing at it. See, I can see this. I have no idea what's going on here. Hang on, just quick.
There it is, and yep, one little star.
I have no idea where it's at, sports fan.
Did you start 2 of them?
There's your voice is going in the background, but I don't have a clue as to where the heck it's at.
Now the calibration distance is different. If you're using direct guide, calibration distance
Got me. It's a mystery.
It's Richard's voice, isn't it?
It's Richard's voice. It is.
It is me.
I don't imagine Richard's playing it on his computer.
No.
You see here, we just want to move the star.
I'm shameless in terms of making mistakes.
I really don't have a clue.
You don't have anything else for that? Go to Force Quit, maybe. It'll show you if there's something else.
No. Unless somehow it's magically coming through.
Did you kill QuickTime completely?
Yeah.
Yeah.
So QuickTime is gone and it's still playing.
That's a hell of a video.
That is weird.
It has multiple redundant.
But we'll take into account the
Hang on here.
and so you can go more into sound.
Could it be playing in iTunes?
From session to session. So
iTunes is not running.
No, iTunes doesn't run.
Is it on your end, Richard?
No.
Sit.
especially if you're mobile or a star party.
Hang on.
There. Good job.
So eventually it'll finish.
Okay.
Obviously, it finished just about the time I brought it up, just to see if there was something else going on. Got me.
You want to try it again?
Yeah, we'll try it again here.
All right.
Okay.
Just one click, Dave.
And don't double click.
What the heck?
Starting in the back.
It's on your other screen, Dave. Don't do that.
I don't think it's here.
It's still playing.
It's playing someplace.
So much easier on PC.
Get out of here.
Try Alt Tab.
No, everything is easier on the Mac. No matter what.
Except when it's doing something weird. See, he's a Mac believer. He runs
Go
Macs.
over to the icon.
I think
Hover your
believer is the
mouse
correct
over
term.
there. You might be able to pause it over on the
With what?
Just put your mouse on the icon.
Put the button there.
Yeah, okay, it stopped playing. Don't click that play.
Well, you have to click that play.
Yeah, quick time to go.
I think you're clicking the, I think he wanted you to do the guiding one, to be honest.
You want to do the calibration, right, Richard?
Yes.
You want to do the calibration.
Calibration comes before guiding, yes.
And like right click and open with something.
Open with something else.
Quick time.
Yeah.
All right.
Play. No, it's playing.
No, not yet. It is now.
Okay, yeah.
That's weird.
This is much better.
We show you how to successfully calibrate your auto guider in SkyX camera add-on. I'm using the Orion Starship auto guider here, and one of those short, wide field guide scopes that are very popular these days. I've taken a 4-second image with no subframe just to evaluate the field and look and see if I have enough stars at this exposure time, and I can see I do have some stars here from. We're looking for two things here. We want a star that's sort of by itself, and we need a star that's not saturated for best results. So I think I found one. I'm going to draw a subframe around it and take another exposure of the same length and evaluate that and take a look. There it is, and yep, one little star by itself, not saturated, so that's very good. Note here I'm using direct guide on a Paramount for this video. I could also use the guide relays if I have a cable connected from the camera to the mount. Now the calibration distance is different. If you're using a direct guide, calibration distance is in arc seconds, and if you're using relay cables, it's not really distance, it's time, it's actually in seconds. Now how many seconds or how many arc seconds you use really varies depending on the scale of your auto guider and your auto guider scope. So you can see here, we just want to move the star a little bit, and this may require a little trial and error on your part. You don't want the star to move too much within the frame, but you need to move enough to where it registers as some motion. You can see here the Y component looks a little bit longer than the X component, even though it's the same distance in arc seconds, and that is entirely a function of your declination. And we have successful calibration, so we're ready to go. Very nice. The nice thing about auto guiding with the camera add-on too is it takes into account your declination, so you only need to calibrate one time, pretty much anywhere in the sky. I don't recommend calibrating in Polaris, for example. But we'll take into account the declination, and so you can go anywhere in the sky and successfully auto guide. It's also persistent from session to session, so if you don't move your guide scope or camera around, you can come out the next night and just be calibrated and ready to go. And this is a very nice time saver, especially if you're mobile or at a star party. You're ready to go at the beginning of every night.
Okay, so I hope all that came through well. So I did mention something in the video that I hadn't talked about, direct guide. This is also a Paramount specific feature. So usually when you guide with a guide camera, there's a set of relay cables that goes from the guide camera to the mount, and a set of relays. And the Paramounts have this capability too for people who just have to have it. And the guiding software will send a pulse command to the camera, and then it fires an analog relay that tells the motors to speed up or slow down. With direct guide, we actually send commands directly to the control system on the mount. The difference is, it's kind of like the difference between a chainsaw and a scalpel. The direct guide is a much finer grain control right to the control system, and at a much higher frequency than what you can get with an analog relay bumping the motors. So best guiding gets you so far. Direct guide using the Paramounts is a better way to guide. Again, finer grained adjustments more frequently, or at a certain frequency helps improve your contrast. The next video is on guiding itself, and we have dithering. I think a show how that works. Are you brave enough to hit play on that, David?
We'll try that again.
All right.
Last time, I showed you how to successfully calibrate your auto-guider.
So far, so good.
I'm going to show you how to start an auto-guided session and what successful auto-guiding should look like. We begin with a full frame exposure from the guider camera for 4 seconds. This is long enough to provide us with more than a few stars to choose from and smooth out the effects of scene. I recommend picking your own guide star. In a noisy guide camera without a shutter for taking auto darts, hot pixels may be a problem, and this problem is trivial to get around by simply handpicking a good candidate guide star yourself. Make sure you do not pick a guide star that is too bright and saturated. Here I've located a good candidate, and I'll draw a subframe around it and take another exposure to inspect the field and double check for saturated pixels. This looks like a good candidate guide star, and I'll select this star for auto guiding by double clicking it and then pressing the auto guide button. When guiding, a small subframe will be automatically placed around the guide star. It may not be too pretty, especially if you're using an 8-bit guide camera, but you can adjust the appearance of the star to your own taste with the histogram tool. The display of the guide star does not affect guiding accuracy, for this is purely a cosmetic feat. To really evaluate how effective your guiding is, you need to display the graphs dialog. This shows 4 important metrics for guiding quality. First is a 3D display of your guide star intensity. A scatter graph shows 2D corrections in real time, and a nice tight gathering around the center is ideal. Relative intensity is shown by the green bar, and finally, a log of the X and Y corrections is shown to further monitor the stability of your guiding over time in each individual axis. Here's an example of almost textbook guiding for 20-minute subs. In this case, I have chosen 5-second exposures on the guide star and a 3-second delay between guide exposures. We don't want bouncy guide stars, and 5 seconds smooths out the scene. An additional delay ensures that I'm only making gradual and occasional bumps to an amount that is already tracking well. We have a nice symmetrical guide star that shows an excellent profile in the 3D graph display with a signal well above the surrounding pixels. The scatter graph shows a little up and down oscillation that is occurring, which is more clearly shown in the y-axis log graph here. This sinusoidal pattern is typical in right ascension and is nothing more than the periodic error of the mount being guided out. The top log shows a consistent push in one direction because of a drift in declination. This is due to a slight polar misalignment. Basically, the auto guiding is doing its job. For best results, guiding corrections should really be small gradual adjustments to the mount. In my settings, I have the minimum movement set to 0.1 arc seconds and the maximum movement to 1 arc second. I'm saying unless it's at least 0.1 arc seconds, don't make a correction. And I'm saying don't move more than 1 whole arc second at a time. These tended settings keep the guider from trying to move the mount all around chasing the simulated star due to poor scene conditions. I'm also dithering between exposures in this example. I've selected a 1 pixel dither in guide camera pixels, and I've set the settle threshold to 0.3 pixels, which for the large scale at which I'm shooting here is sufficient. You can see here the previous exposure has just completed, and the dither operation has begun. The guider sees the dither as 1 pixel error and will attempt to correct this by moving the guide star to its new location. This will take a few exposures in this example because, recall, I told the guide camera not to make corrections exceeding 1 arc seconds. You could spend a lot of time fine-tuning these parameters for your particular mount and object choices. But remember, I set the settle threshold to 0.3 pixels, so a new exposure will not begin until this criteria is met. I can also introduce an additional delay after the dither if I need to allow for some extra time for settling, or tighten up the settling threshold parameter. Some experimentation with your particular system will be necessary to get the optimum results in your environment. As you can see here, in this 20-minute narrowband exposure, I have good round stars with no trailing or elongation. Perfect, just what I want. Now the dither operation is completed, and we begin the next exposure in our series. We are well on our way to a collection of nice, clean subs, and hopefully another deep sky masterpiece.
That's it, right?
That's it.
Okay, good.
No mysteries this time.
Okay, yeah. So key features of the guiding is calibrate once. You don't have to calibrate in different areas of the sky. Also, I didn't mention it in the video, but the orientation of the guiding camera doesn't matter. If you're 90 degrees, you'll get that sinusoidal pattern where you can see the periodic error of your mount, assuming you haven't trained it out. But if your guider is kind of cockeyed or to the side, then those signals will be mixed, that declination drift and the periodic error will be mixed together, and you won't see it quite as clear. A lot of mistake people make when they're guiding is they try to update the camera or try to update the mount every second. They want real fast guiding rates, and usually all you're doing is chasing the seeing around when you're doing that. If you have a reasonable polar alignment, if you think about it, you can go 30 seconds or a minute even without making any guiding corrections. Why do you need to do corrections, every second or so? So I always aim for about at least 5 seconds on my guider exposures. And of course the Paramount doesn't have any backlash to speak of, so that's also a big boon for guiding as well. How many of you are portable imagers?
Almost everybody.
Almost everybody? All right. And so I know your club has an ME now, and I presume that's going to be for shared use for everybody?
Yeah, that's correct.
Okay, all right. And so we're actually having a Paramount workshop hands-on in the desert in November, and David is coming, and you're bringing somebody with you, David. Is he there?
He's there.
Who's coming with David? All right. I'll look forward to seeing you there then.
Scott Dixon.
Right. Okay.
Yeah.
All right. So once you're set up on a pier in an observatory, you're going to calibrate one time. You're going to run your T-point model one time. So a lot of this is just one-time setup. In one evening, in a couple of hours, you can be totally ready to go. And then every night after that, you just turn it on and home the mount. And as soon as the temperature of the sky is appropriate, you'll be ready to rock. So that's ideal. So I wonder if I can show you some other features of the software. I'm going to go back to screen sharing. Or yeah, we'll just do that. There's the desktop, and here's the sky again. So we have, we have the ability to take a series of images. You can set it up, to take so many exposures with a particular filter, and you can add them. You can go finish up one series and then do the next, or you can actually do round robin. If your filters are parafocal, sometimes I like to do LRGB, LRGB, or RGB, RGB. Because again, as a portable imager, sometimes you never know. You may only get 2 or 3 hours. You may only get an hour of imaging in, and there's nothing worse than getting an hour of red and 3 blues, and then you're done for the night, and you can't you can't get anything out of it. If you have filters, we also have filter focuser offsets. That was the wrong button, and you can actually train your filter so that you know what the offsets are for your focuser. So I'm kind of fortunate. I have 2 scopes that I use primarily for imaging, and I have 2 sets of filters that are parafocal. And so I really don't need to do this myself. But if you have a mix of filters from different vendors or different manufacturing batches, you could say, the luminance filter is 10 off from everything else, or negative 10 from everything else. So when you switch to the luminance filter, it knows to move the focuser back, say, 10 clicks on the focuser. And I'm going to take that out before I forget and leave it in there and screw up one of my imaging runs later down the road. So we also have rotator support, which is and dome support. Those aren't very interesting to show with the simulators. And so file naming conventions are kind of cool. You can set these up so where your autosave folder is, and we have these little tokens you can put in here. So you can automatically append the exposure time, the bin mode, which filter you're using, what the temperature of the camera was. I find that to be very useful when I look at a folder full of images. I want to know which ones were red, which ones are the blue, and which ones are the green. And you don't want to have to go in and change the file, the file name every time you change filters, obviously. And you can set it up differently for bias and dark frames. So I like to put the word bias in my bias frames and dark in my dark frames, and same thing for flat. Just makes them easy to spot when I'm going through my data later. One thing we don't do on the Sky really is image calibration. We do have a reduction function, so you can do auto darks. We do have full calibration. You could build a library of darks and flats and have it applied to images automatically as you take them. But unlike in the CCD soft days, we're not trying to do stacking and image and alignment, those sorts of things. I think Maxim is still doing that, but PixInsight and CCD Stack, there are a number of good tools on the market that do an exceedingly good job at that. So we're focusing on camera control, mount control, ease of use, those sorts of things, for the imager. And I'm going to switch back to the audience now. There I am. We also have full scripting support. We have the legacy VB script for the Windows guys who are using the Sky 6, and they've got some scripting things set up. But we also have a JavaScript engine now, and everything in the Sky is exposed through JavaScript. JavaScript's a very popular scripting language for the web. It's a very easy one to learn for people, self-taught programmers, and it's cross-platform. So, and you can send it over a socket, which is a network protocol. So I can set up multiple computers and have one computer, a remote computer, controlling the computer that's controlling the mount, and send JavaScript commands over a network socket to that computer remotely. And because it's programmable, really the whole Sky is really programmable. You can set up imaging runs. Like I do dithering with ProTrack. So what dithering really is, it just moves the camera a little bit between each exposure. And most dithering algorithms are wired to the auto guider. Well, when using ProTrack, I can just say expose for 10 minutes, move the camera and 3 arc seconds to the left, expose for 10 minutes, and I can write a program, a very short program with a loop that goes through and does that. Some of my best images have been unguided exposures, but have also been dithered using our scripting interface to the Sky. And I think I've covered just about everything at least at 40,000 feet anyway at this point. And we're about an hour and a half in. I think that's probably about typical. Any questions? I guess any kind of questions about anything is fair game at this point about what I've talked about or shown you. Yes.
Do you have tutorials available on the Sky?
No, we have a very comprehensive manual, and I'm
560 pages long.
Ow.
Yeah. So I've spent 15 years teaching teaching at the college level, and we've had these discussions, and they're well-known learning styles, and some people really learn best from printed material. Unfortunately, that's about 3% of the population, and so it's not really most people. So the 3 videos that I've shown you are our first attempts at doing that. We're going to do a series of video tutorials. Sarah Bisk, Steve's daughter, she's our production engineer, and she's done some videos on how to replace the worm blocks, how to re-grease the mount, how to do through the mount wiring. we had a customer who's a friend of a friend, and you know what happens when a customer is a friend of a friend, and you know they get direct line tech support. So this weekend he was running wires through the mount and pulled something loose, and you know the manual is worthless. The manual is worthless, and you know he's looking at the diagram in the manual, and it just didn't make any sense to him. And he found the YouTube video, and he was like, "Oh, well, of course, this is easy." And so different people learn in different ways and can be instructed in different ways. And we think video applies to most people, especially the younger generation who are raised on YouTube and with short attention spans, because none of the adults, of course, have short attention spans. Yes, so we have some video tutorials like the guiding ones that we just had. I plan to redo the polar alignment one. The wind was too strong that day, and I kept squinting because the sun was in my face. But it covered the basics, and so that's the sorts of things that we're working on. And I'm actually retiring from teaching at the college, so I have more time to spend on this sort of thing in particular. So that's about to become part of my job. You know, imaging evangelists go to the star parties, and also start putting together some curriculum, if you will. What we really want to have is a workbook. And when people say, I can't get guiding to work, we say, have you done these exercises? You know, I can't get focusing to work. And instead, a literally step-by-step tutorial. Did you go through that tutorial? Where did it go wrong? If you haven't even looked at the tutorial, well, that's where you should start. So we're going there. You know, the mighty, the MX opened up a lot of new markets for us. The ME was really a professional level robotic mount, and it was used mostly by professionals and by very serious amateurs. The MX penetrated the amateur market quite a bit more for us, where a lot more serious amateurs who didn't have quite so big a scopes or so deep a budgets became customers, and we learned a lot because of that new customer base. And we think with the Mighty the same thing is going to happen. We're going to be bringing in a lot more people, some of whom aren't necessarily as sophisticated an imager, and we realize that if we're going to sell that hardware, we're going to have to teach them how to image, not just sell them equipment. You know, it's not like buying an MRI, but sometimes it is. People you wouldn't buy an MRI and put it in your garage and say, well, I don't know how to use it, and the manual's useless. A lot of times people like to use the explanation of, well, it's not that hard to drive a car. And I like to point out, you forgot probably how you learned to drive a car. I remember learning to drive a car when I was 15, and my mother screaming because she thought she was going to die any moment. And once you're competent, you don't remember what it was like to learn it. And if you buy a high-end piece of equipment, there's some learning curve, and we're realizing that we need to do something about that learning curve ourselves. We can't just rely on other people's tutorials and videos, and it'll reduce a lot of customer frustration, and it'll reduce our own tech support if we can do a better job of that. So we're about to focus a lot more on, like I said, the portable market, and we're about to focus a lot more on creating these sorts of tutorials and educational materials. So we really want to be a source of information for how to image, not just simply buy our software, buy our mount, and then figure out how to use it. We think we know the best practices for how to image, and so we're going to try to do that as well.
Hey, Richard?
Yes?
Could you, on the-Sky X, could you summarize what's in X versus X Pro, and what are the add-ons that are...
Oh, yes. Yes. The starter package is the SkyX Student Edition, and it's basically high school level astronomy, you know, with a fairly shallow set of databases. It would be useful for a small telescope or binoculars as well, for finding objects that way. The Sky Sirius adds telescope control and deeper databases. so that you can do automated, go to telescope pointing, find objects and flew to them. Primarily the deeper databases and the scope control is really the biggest difference between the Sky Student and the Sky Sirius. The Sky Pro is really aimed at imagers. It includes out of the box the image link plate solving capability. It includes out of the box the scripting capability. A lot of people do use third-party applications to run the Sky, to run their Paramount. They'll use somebody else's camera control software, and that camera control software will take a picture, send it to the Sky, do the plate solve, get the coordinates back, and do that sort of thing. So scripting, image link, more database support. So the databases, that's kind of our ultimate database package, and extensibility. The add-ons, the camera add-on is $199, and that gives you integrated camera control. And it's actually built into the Sky already. It's just a serial number, so there's nothing to install. And it comes with like a 90-day, well, maybe 60-day now, but it was 60 to 90-day free trial. So you can try it out if you don't want to spend the money, until you know that you're going to like it. And at $199, it's very competitive with what anybody else is offering for camera control. And of course, the integration with the Sky, like I showed you, the automated T-point run. You only get that by having the camera control, integrated into the software, or the closed-loop slew, for example. The T-point modeling stuff is for really the more serious imagers, or if you have a Paramount, of course, you get it for free. We actually pay a royalty on that as well, and we've done a lot of customization to integrate it into the Sky and to work better with Paramounts. And T-point.
The T-point came with the Sirius Astronomer version.
No. T-point is a $250. It's a $250 add-on if you don't have a Paramount. If you have a Paramount, you get everything. So Paramount purchased, you get all the software. But if you're gonna piecemeal it, the Sky Pro is like $250. The camera add-on is $199. T-point I think is $250. I'm a terrible salesman. I don't have the exact numbers memorized, and it floats around plus or minus $50. Sometimes we do a sale at a show, that sort of thing. It's well over $1,000 by the time you throw it all together if you bought it piecemeal. So you should consider that when you buy a Mighty. It's really a $5,000 mount and $1,000 worth of software to control it and do all your imaging runs.
Richard, does the closed-loop slew require T-point?
No, closed-loop slew does not. All it requires is Sirius Astronomer and the camera add-on. So the Sky needs to be able to control the camera in order to do that. There was some discussion. At least one staff member was kind of upset because he said people don't need T-point if they have closed-loop slew. And if all you're using T-point for is to find an object, and you're not using it for anything else, that really is true. If you just want to find the target and get on it, and then you're going to guide, and you're not using a Paramount, then closed-loop slew it's a tremendous boon. We've been able to do it for years via the scripting API. Orchestrate did it. All the third-party applications, when they script the Sky, they do it. And we finally got around to making it a button, and a lot of users on our users group totally freaked out when we did it. They were real happy about that, just because it made it so much easier and more accessible.
Another question. There was some there. If you have, does T-point work with only German equatorial mounts, or does it work with a fork mount like an LX200?
Is it a polar fork or an alt-az?
Polar.
Well, wait a minute. A fork so is it a polar fork?
Fork with a wedge.
A fork with a wedge. Oh, yes, that will work.
Okay.
Yes, it'll work with that. It doesn't work with strictly. It does work with alt-az, but we don't have that. We don't have that exposed. A lot of the the professional stuff does that. But like if you have a LX200 on a wedge or a Celestron non-equatorial on a wedge, T-point will work with that. Yes.
Great.
Perfect.
Okay.
Anything else, guys?
Question concerning your new Pinto Pony. If I was happy with your MX Plus with a 40-pound load, would I get similar performance on the Mighty with the same optics transferred from a MX Plus to the Mighty?
Yes. The periodic error. We were just discussing this today. The gears are smaller, so it drove the periodic error up just slightly. But if you train the PEC trains down to under an arc second, regardless of which mount you have. But it's still, we're guaranteeing. Okay, so this is going to be on YouTube. I might be in trouble for this. We're quoting 10 arc seconds, but the one I have is only 6 arc seconds, and the one Tom has is only 2.5 arc seconds. So it's varying a little bit, but it's very small. That is the only thing I think you would notice between the Mighty and the MX Plus for small payloads. But otherwise, it works exactly like the Paramount does. It's the same control system. It's actually the same motors. We use the same motor in the Mighty as we do in the MX Plus as we do in the ME2. So there's there's a lot of synergy there. But it's a Paramount. It's absolutely a Paramount.
Is the encoders on the motor shaft or on the mount shaft?
They're actually in the motor, and then we have the gear ratios figured out. So you get about a couple of million ticks per revolution. So it's down to under an arc second resolution, and then the homing sensor homes it, and so it knows exactly where it is, and then it uses that to move it around. We do plan to come out with an absolute encoder kit for the ME2, and we may do it for the smaller mounts. It may not really be economically feasible. There's a lot of talk about absolute encoders, and our position is, number one, a lot of our competitors need absolute encoders to match our performance because of T-point and, of course, the machining and the way we build the mounts. But absolute encoders do two things that might be useful for Paramount owners. One is it eliminates the need to do periodic error correction training. In my view, I would much rather spend 20 minutes training the PEC than I would spending $5,000. But the absolute encoders will get rid of the periodic error, and you don't have to train it down. For mount modeling, it does reduce the number of samples you need to get a good model. We haven't exactly characterized how fewer samples you need, but regardless of whether you're using our mount or somebody else's mount with absolute encoders, you still have to have mount modeling, because knowing where the shaft is does not tell you where the telescope is. All that equipment on there is flexing and moving, and that has to be modeled somehow. A good friend of mine has an AISIG mount with absolute encoders, and he can go for 20 minutes unguided just like you can on a Paramount. Of course, he spent a lot more than he did for a Paramount. But it's not because of the absolute encoders, it's because of the mount modeling software that comes with it. There's a lot of, I guess, urban legend stuff about absolute encoders. It's like if I get new tires, my air conditioner on my car blows colder air. Some of the claims that people make are really ridiculous. But really, what you get, it does without question, it does eliminate the periodic error. So there's no need to train the PEC out of your mount. You will have zero periodic error with absolute encoders. And you still have to model the mount. Whether you use T-point or competitors, you still have to model the mount. Somebody has to model the mount. And it does reduce the modeling time a little bit. And we're not sure how much, but it does. And we've made quite a bit of progress on that internally. So you may hear something about it at the Arizona show at the end of the month, or if not, probably by the end of the year. I think we'll have some announcements to make about the absolute encoders. And that was probably way more information than you were looking for.
Good.
Yep. Okay. Anything else?
Anything else, guys? All right, I'm gonna stop the broadcast.